and tell me, how many simple machines are there? How many simple machines are there? Myra, do you remember?
6.
Good. There are 6 simple machines. Very good. Okay. Who can name one of the 6 simple machines and come write it up here on the smartboard for me, please? Okay, because we know that there's 6. So, wheel and axle, the inclined plane, pulley, lever, wedge, and the screw. Those are the 6 simple machines to make what? What do simple machines do? What's their job? What do they do?
Make work easier.
Good, good. So one thing that we're going to see and we're going to compare is how they kind of make work easier. Now, let me see. Over here, I have a chair, okay? And as you guys know, because you put your chairs up when you leave the classroom though, is this chair light or heavy? Heavy. Now, I have to, of course, lift this chair. What am I using when I lift this chair? Raise your hand. But what part of my body do I need to lift something in order to get that chair on the top of the desk for me to get ready for the floor to be clean? What do I have to do, Abraham? I have to pull, very good, which is a force. We know I'm pulling to lift it up. So what am I using to pull the chair up? My arms, right, and my arm muscles. What else, though, when I lift?
Your back.
Oh, raise your hands. Thank you, Jada. Okay, my back, right, because I have to bend over and pick it up to lift it up. So what if I had to do this with every single chair in the classroom? Raise your hand and tell me, what's going to happen if I have to do this with every single chair in the classroom by myself, if I did it on my own? Monique, what would happen?
Your back would start hurting.
Whew, my back would start hurting. What else might happen? Valina?
You might hurt your arm.
Right, I might pull a muscle, I might hurt my arm. All right, we're going to kind of see if this would be uncomfortable for maybe something a little bit lighter than a chair, okay? So first thing we're going to do is I'm going to kind of split you up into partners, okay? And we're going to try lifting a load. And I want you to lift the load that I'm going to give you. I'm not going to tell you what it is yet, okay? But I want you to lift the load from the floor, okay? You and your partner will switch turns, but you lift it off the floor and you'll do it 15 times. Beyonce, what about you? How was everything when you did the lifting of the loads?
I hurt my knee and my back, but it wasn't hard. It was easy because it wasn't heavy.
Okay, good. So,
Number 2,
oh, I'm sorry. Yes, go ahead.
it wasn't very heavy because it was very light, but bending down and coming back up, it hurt. It felt like I got hit in the back with the foot.
Okay, good. So, and I like that you use that metaphor, compare it to something. So imagine though if you are, because we knew our industrial engineers, they were lifting stuff and doing stuff at the potato chip factory, right? And they were lifting potatoes. Can you imagine bending down, lifting them all day? I mean, you guys just did that for a few seconds to do it 15 times. Can you imagine bending over, picking something up all day long, how you would feel at the end of the day?
Yeah.
Right. Even though it's potatoes, and if you do a few at a time, like if you do a bag of potatoes, man, your back, your legs, everything would probably be sore, wouldn't it?
They must get paid a lot to do that.
Well, but that's where the simple machines came in. Remember? Instead, from the floor, the conveyor belt or the inclined plane would bring it up. So we're going to test that. We're going to be the engineers, and we're going to test which simple machines, right, are better for lifting things a certain amount, right? Because you guys said bending over to pick that water bottle up and down, right? You said that was just, that was awful, wasn't it, right? Doing that. So the workers to move and to be more comfortable, okay? So it's all about comfort and making it easier to move, okay? Being comfortable. Those are the main things to remember with the ergonomics, okay? So when I use a simple machine to say lift, that instead of doing it by hand, right, and pulling upward, so is it easier with that simple machine? Was it more comfortable, okay? Was it really hard or was it easy? That's what you want to think about with ergonomics. We're going to go around and we're going to start testing these simple machines, okay? And what we have to do, okay, is we have to make sure that we do things, let's say the same height or the same weight when we compare them. Why do you think that is? Why am I going to lift the same amount of weight and only lift at the same height? Why would I do that? Jada, why would I do that?
You get accurate results.
Accurate results. Good. Because when I compare things, I want to compare apples to apples, right? That's a saying. Instead of apples to oranges, because they're totally different things. You have to first see how many newtons of force it takes to move that load by hand. So we're actually going to fill that in today. We're going to test that. So first I have to show you what the load is, okay? And the load is the same load that you use today, okay? Here's my load. It's a ½ liter water bottle. Now, I'm going to measure how much force was used to move my load with this. What's this called? Can anyone raise their hand and tell me what's this called? Zaire?
A pulley.
Oh, good try. Good try. It's actually not a simple machine. It's not a pulley. That was a good try. Cassidy?
Spring scale.
Very good. It's a spring scale. So if I were, say, over here at the, who can raise your hand and tell me what station would this be? What station would this be? Raise your hand. What station is this? Sharice? Lever station. Very good. Now, Beyonce, you said something about the fulcrum. Where's the fulcrum at the lever station? Any idea?
The ball.
Very good. Where the wiffle ball is. Very good. So right here, okay, I have my lever situated and I have my fulcrum, right? And how would I be able to lift the load with the lever? How would I lift this load with my lever? Who can come up and show me? Abraham, can you come up and show me that? There you go. A little bit higher. There you go. Perfect. Good job. Thank you, sir. Go ahead and set it back down nicey nice there. Very nice. All right. Good job. So he used his spring scale. He lifted from here, okay? And he made sure that he lifted at 6 inches. You can see up on your chart, look at A, B, and C. Look at A, B, and C. Let me zoom in on that so you guys can really see it. What do you notice about the fulcrum for A, B, and C on the lever station? What do you notice, Michaela? Not in the same place. Over here at your lever station, you have little pieces of masking tape, okay, where you and your group, because you're going to have more than one person over here, are going to have to carefully move the dowel rod, that's this long piece of wood, to the different places. And actually, Miss Sitters, okay, is going to be over at this station as well to make sure that we can slide it through to get to the next part, B. Okay? So here I had letter C, here's A all the way over here, and here's B. But also down here on the table I have directions on how to measure it when I move the fulcrum to different positions. Because we're going to see if it's easier when I move my fulcrum and I lift my load 6 inches up off of the ground. We're going to see which position is easier, right? The next one is over here at the, who can raise their hand and tell me what station do you think this is?
Oh, no.
Sharice. Oh, no. Cassidy? Incline plane. Very good. So right here is the incline plane station. And again, you have a long board with directions and the short board with directions. Okay? So for example, right here it shows, okay, you have your 6 inches, okay, and you have your load. It says place the load at the bottom of the incline plane, pull on the spring scale to drag the load up the incline plane, and record reading from the spring scale on the incline plane packet. So again, you're going to have your load. Okay? You want to know how much it is by hand, right? So what did we say it was by hand?
5.5 inches.
Okay, right at the top. Go ahead and write it in again. 5.5 newtons. Right in that top box. Okay? And then I need someone to come up, okay, and pull our load up the long board of the incline plane. And there's a start and a stop with the tape. Good. She made sure it's on her spring scale, and she's pulling. She's going to look at her spring scale and read the newtons. so she can record it. Now, how many times do you think Felina should do this to get a good reading, an accurate, raise your hand, accurate reading to make sure she does it right? How many times do you think? 3 times. Good. Just like we did over there with by hand, right? We did about 3 times. Here's one wheel and axle with your load inside. And of course you pull with the spring scale. I'll fix that for tomorrow. And then look at this one. Raise your hand and tell me what's wrong with this cart. What's wrong with this cart? Michaela, what's wrong with this? Ah, so this is a little different for our simple machines, huh? Do I have a wheel and axle on this cart? No. So I have a cart with no wheels, and I have a cart with wheels and axles. So you're going to pull the load without the wheel and axle on a cart, as well as with the wheel and axle for your cart. Okay? You're going to have both. There is also a start line and a stop line at 6 inches. Again, 6 inches, 6 inches, 6 inches, lifting or moving the load. When you do this, okay, I do want you to try, and I'll make sure you have a new spring scale. I want you to try pulling, dragging this just on the floor, okay, to see how many newtons you get with a spring scale, all right? So you're going to use a spring scale, okay, attached to this. I'll put a little rope around it for tomorrow, just to pull it along the floor to see if it's different because you're pulling it by hand. We need the load by hands, don't we? But we have to pull it the same direction, okay, that we do on our cart. We have our 2 pulley stations here. We have our double pulley, and we have our single pulley, okay? We have both. The directions are right here. Pull down on the spring scale to lift the load 6 inches off the ground. Who can come up and show how to pull the load 6 inches with the double pulley? Who can come show that? Daishwan, why don't you go ahead and do that? And then I'll have someone try on the single pulley as well. Okay, so he's holding his spring scale. He's going to lift, measure the newtons, but make sure you get 6 inches. Keep going. Pull, 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 pull. Good. So the end of the water bottle right there. See how that tape line is? Okay? With the bottom? Good. And then I'll set it down nicely. Good job. Okay? So again, he's going to use that tape measure for that 6-inch height because we want it the same. Consummate actually want to come up and do the single pulley now to see how we do with that one. Again, you want to look at your 6-inch mark as well as the newton mark. Go ahead, try it again. Just 6 inches. Looking at your scale, see how many newtons? Good, perfect. How many newtons was that? She got 5 for that one, so we'll have to see. Good job. How the single pulley versus the double pulley, what one might work better. We're going to come together. You're going to share your results with me, and I'm going to fill out our class results. What you guys thought as far as which simple machine was the best and why it was the best for lifting that load. Looking at your ergonomics, was it comfortable and easy to lift with your simple machine? Or the newtons, how many newtons it was. What would be better, a lot of newtons or a little bit of newtons? A little bit of newtons. Very good. So less, right? Less is better.
The lesson 3 definitely has a lot of preparation that's needed. So you have to be sure that when you're preparing for it, that you make sure you read exactly how the simple machines are put together and where in your classroom they can actually be placed to use them properly. Plus, on top of the preparation before, you have to make sure that they're set up in a way where the stations, students won't be on top of each other and they have some space between them so they can still work together without bumping into each other. So while setting it up, I try to look at that as far as the classroom and making sure they're spread apart first to make sure they can kind of fit the number of groups that you need. The next thing that I try to do is, since we've been doing groups since day 1, I try to make sure that they have clear expectations and rules as what the classroom management and behavior needs to look like. And we try to role play sometimes and say, okay, well, if I'm seeing cooperation, what would that look like? Or teamwork, what would that look like? And talking about being respectful to each other and making sure that they treat each other and the materials with respect, which is something big. Again, they seem to think that they're playing with toys, but they have to understand that these are tools and they have to treat them that way instead of at play.